The underwater realm, long shrouded in mystery, is becoming increasingly transparent. China has developed a game-changing technology with the potential to reshape naval warfare. Researchers have devised a method to detect even the stealthiest submarines, including the U.S. Navy's formidable Seawolf-class. This breakthrough centers around tracking the faint magnetic signatures generated by a submarine's wake. Submarines, once considered invisible hunters of the deep, rely on stealth as their primary defense. The Seawolf-class in particular is renowned for its acoustic stealth, making it exceptionally difficult to detect using traditional sonar. However, this new Chinese technology exploits a different physical phenomenon, the magnetic wake, to pinpoint these underwater predators. This development has sent ripples of concern through naval strategists worldwide. The ability to detect submarines, particularly the quietest and most advanced ones, could significantly alter the balance of power in the oceans. To understand this groundbreaking technology, we must delve into the physics of Kelvin wakes and their magnetic properties. A Kelvin wake is a V-shaped disturbance on the water's surface, trailing behind any moving object. Submarines, despite traveling underwater, also generate these wakes. The creation of a magnetic signature from a Kelvin wake is a subtle but detectable phenomenon. As a submarine moves through seawater, it disturbs ions present in the water. These disturbed ions interact with the Earth's natural geomagnetic field. This interaction produces a faint magnetic anomaly, forming a detectable trail behind the submarine. Crucially, unlike a submarine's acoustic signature, which can be minimized through advanced silencing technologies, this magnetic wake is unavoidable. It serves as an inherent fingerprint of a submarine's passage through water, detectable by sensitive magnetometers. The heart of this technological breakthrough lies in the meticulous research conducted at Northwestern Polytechnical University in Xi'an, China. Scientists embarked on an ambitious project to model and simulate the magnetic signatures generated by submarine Kelvin wakes. Through complex simulations, researchers were able to quantify the magnetic signatures produced by submarines under various conditions. Their findings revealed a direct correlation between a submarine's speed, depth, and hull dimensions, and the strength of its magnetic signature. Increasing a submarine's speed, for instance, was found to amplify the magnetic intensity of its wake tenfold with every 2.5 meters per second increase. Similarly, the study demonstrated that a submarine traveling at shallower depths produced a more pronounced magnetic wake. For every 20-meter decrease in depth, the magnetic field strength nearly doubled. Interestingly, the research also uncovered how a submarine's hull dimensions influence its magnetic signature. The implications of China's magnetic wake detection technology are far-reaching, potentially altering the landscape of naval warfare. The findings from Northwestern Polytechnical University suggest that even the stealthiest submarines, including the U.S. Seawolf-class, are vulnerable to this new detection method. Simulations indicate that a Seawolf submarine traveling at a speed of 24 knots, or 12.5 meters per second, and a depth of 30 meters, generates a magnetic field strength of 10 to the power of -12 Tesla. While seemingly minuscule, this magnetic signature is well within the detection range of existing airborne magnetometers. This means that areas once considered safe havens for submarines, such as the vast expanse of the South China Sea or the strategically vital Taiwan Strait, may no longer provide reliable cover. This development has sparked concern among U.S. defense officials and naval strategists. The ability to detect submarines with such accuracy undermines a core tenet of naval strategy: submarine stealth. As a result, the U.S. Navy may need to rethink its deployment strategies, particularly in regions where this technology is likely to be deployed.